Now let's study projectile motion on inclined plane. In case of inclined plane, we are going to discuss projectile motion under two cases. Say first we'll take up case 1, that is projection of a particle up the plane. Say we are having an inclined plane of inclination theta, and say from bottom a particle is thrown with the initial speed u at an angle alpha from the inclined direction. The particle goes up and finally lands somewhere on the inclined plane, say at point A. To analyze this projectile motion which is there on inclined plane, we consider point of projection as origin. Along the inclination direction we consider x-axis, and perpendicular to the inclined direction we consider y-axis. If we resolve the initial velocity, we can say in x direction the particle is moving, or it started with the velocity u cos alpha, and in y direction it started with the velocity u sin alpha. If we talk about gravity, gravity is obviously acting perpendicular to ground in downward direction, this is the ground. If we resolve this gravitational acceleration along the incline and perpendicular to the incline, we can see if the angle of inclination is theta, this angle will also be theta, and acceleration perpendicular to incline will be g cos theta, and along the incline its component would be g sin theta. So here we can say a particle which started in y direction with the initial velocity u sin alpha, it was retarded by g cos theta, and along x direction it was started with u cos alpha, it is retarded by g sin theta. So here we can see that initial velocity in x direction is u cos alpha, and acceleration in x direction is minus g sin theta. And along y direction initial velocity is u sin alpha, and acceleration in y direction is minus g cos theta. Now, if we talk about the time of flight as well as maximum height and range of this projectile on inclined plane, we can calculate the time of flight by using the rectilinear motion in y direction. As the particle starts with u sin alpha, goes up, reaches the maximum height when velocity in y direction becomes 0, and then it comes down. So the time it will take in going up can be simply written as uy upon ay. So in this situation we can simply calculate the time of flight t by y direction motion, where it was thrown with the initial velocity uy and acceleration ay. So we can simply write time of flight as twice of uy upon ay. It can be written as 2u sin alpha divided by g cos theta. Acceleration as ay we already taken negative, that's why it is coming, and here we are using the relation vy is equals to uy minus ay into t. So this vy becomes 0 after time t, so we can write the value of ay as g cos theta, or if you wish you can use plus ay, and ay you can write as minus g cos theta. This is the time of flight which we use. Similarly, in y direction we can also find the maximum height attained by the particle. Here maximum height can be simply attained by using uy square divided by 2ay. Because it was thrown up with the velocity uy, here we can use the relation v square is equals to u square minus 2gh. So here final velocity in y direction we can take as 0 is equals to uy square minus, instead of g we are taking g cos theta, or ay is minus 2g cos theta into h, if h is the maximum height. So here we can get the maximum height as u square sin square alpha divided by 2g cos theta. This is the maximum height attained by the projectile. We can also calculate the range of projectile by using the x directional motion, as it is started with the initial speed u cos alpha, but it is retarded by g sin theta. So we need to calculate the distance traveled along x direction in time of flight with initial velocity u cos alpha and acceleration minus g sin theta, as it is retardation. So we can also calculate the range of projectile. A range of projectile can be simply given as u cos alpha into time of flight minus half g sin theta into time of flight whole square. On substituting the value of this time of flight, we are going to get this range. So here we are just using this relation, this OA range is equals to uxt minus half axt square. You can also take this positive and put ax as minus g sin theta. This will become negative. So these are the general parameters related to projectile motion on inclined plane if it is projected up the plane. Let's discuss the second case of projection down the plane in case of projectile on inclined plane. Say if we are having an inclined plane having angle of inclination theta, and if a body is projected down the plane at an angle alpha with the initial speed u, we can see again it follows the projectile. Here along the incline we consider the x direction and perpendicular to the incline we consider the y direction. Again we can see that in x direction its initial speed was u cos alpha, and in y direction the initial speed would be u sin alpha. In this situation g would be acting in downward direction. So if we talk about the components of acceleration due to gravity, so we can say normal to incline its acceleration will be g cos theta, and along the incline its acceleration will be g sin theta. In this situation we can see acceleration in x direction is supporting to initial velocity. So along x direction its velocity will continuously increase, and in y direction as g cos theta is opposite to u sin alpha, so u sin alpha will decrease. It will first move up. When it will reach its maximum height, its vy becomes 0 and then it comes down. So we can again calculate the time of flight by using the y directional motion, that is by using uy upon ay, twice of that. We can find out the maximum height by using y directional motion, and then from x directional motion we can find out the range OA. So here if we simply calculate the time of flight can directly be written as twice of uy upon ay. This will be 2u sin alpha by g cos theta. The result remains same. If we find out the maximum height of projectile with respect to this inclined plane, if this is the maximum height, this can be simply written as uy square by 2ay. This will be u square sin square alpha by twice of g cos theta. And as far as range is concerned, in this time we need to calculate the distance traveled in x direction. So if we talk about range along inclined plane, this range along inclined plane can be given as r is equals to u cos alpha into t. Now as acceleration is supporting, it will be plus half g sin theta into t square. Substituting the value of t will get the range along the inclined plane when the particle is moving down the plane. Now if we analyze the maximum range of projectile on inclined plane, and we have studied about two cases of projection, one is up the plane, other is down the plane. We can simply write as the range can be calculated by using ux into t plus minus half acceleration in x direction into t square. Here we have discussed that acceleration in x direction is equals to g sin theta. It can be positive or negative depending on the direction of acceleration. When we throw the projectile up the plane, it is retarding, so it will be negative. When we throw the projectile down the plane, it will become positive because it supports initial velocity. In this situation, the time of flight depends on the projection angle. So here we can simply state r will be maximum when dr by d alpha is equals to 0. This is quite a complex differentiation, and the result will become quite lengthy to be analyzed over here. So I just write down the direct result for you, which you can directly use in various applications. Solving this, we get the maximum range along inclined plane. This given as a maximum range can be written as u square by g 1 plus minus sine theta, where theta is the angle of inclination. Here positive and negative sign is used in various cases, like positive sign we use in case of projection up the plane. So when particle is projected up the plane, the maximum range will be u square by g into 1 plus sine theta, and here negative sign is used when we project the particle down the plane. And here if you take theta is equals to 0, that is obviously if angle of inclination is 0, this becomes a horizontal plane, horizontal ground we are talking about. So you can simply state the maximum value of range is u square by g, which we already studied in case of horizontal projection when theta is equals to 0 and alpha, the projection angle will be 45 degree. That is for the case of horizontal ground.